So today we have a guest speaker. We're honored to have Mike Lacrosse. Mike is a former architecture student from King State College. It wasn't a long time ago. And now he's a founder of this company, BVH. So I assume that you will speak about the company, or because I think it's interesting for the students getting to know that, well, there are other aspects in architecture other than design. This is an engineering company devoted to building commissioning. So I think he will explain everything. And Mike, the floor is yours. Go ahead.
Great. Thanks a lot, Fernando. So yeah, hi guys. Glad to jump on here and talk to you for a bit. Yeah, so a little bit about myself, like Fernando mentioned. You know, I was a Keene State student myself, and I graduated back in 2012 from the architecture program. So yeah, it hasn't been that long. So you know, following you know my departure from Keene State, I got involved in a thing called commissioning, and I had sort of become the right-hand man of a guy that owned a small company in Vermont that was eventually bought out by a much bigger company called BVH Integrated Services, which is a Connecticut-based company. There's an office in Bloomfield, Connecticut, as well as one in Newton, Massachusetts. But the home office is down in excuse me, down in Bloomfield. I actually live right in Chesterfield, the next town over from Keene. Even before everything with COVID, my work has been largely remote. I'm either in the office writing reports and that kind of thing, which doesn't necessarily require being in a sort of conventional office space, or I'm in the field, on projects all across New England. So actually, the Keene area is pretty central to most of my travels for any of my field work. So working remotely, like I said, even before COVID has been sort of the norm for me. And in fact, our whole envelope department, building envelope department is all entirely remote, even before COVID. None of us have worked out of a sort of a formal office. So there's some nice flexibility in that. But I just wanted to maybe there's not a great way to do this, but if you can answer yes to this question, chime in. I mean, has anyone heard the term commissioning in any form? Retro commissioning, envelope commissioning, just commissioning. Is that a term that anyone has heard up until it's been mentioned today? And if so, do you know anything about it? Yeah, so I'm not surprised by that lack of response. Commissioning as a field is one of these sort of lesser known niches in the design and construction industry. And I'm going to get into a specific piece of that called building envelope commissioning today, which is a sort of a subset of commissioning as a whole. So what I do is focused around the building envelope. The title of this presentation is called Facilitating Higher Building Performance. And as we go through it, my hope is that you'll sort of understand that this process of commissioning is really about helping the design and the construction of a building get to a place that is better performing than it would have been otherwise without our presence. So let's get into it. What do we mean when I say, envelope commissioning, or more specifically, when we say envelope, what parts are we talking about of the building? Any thoughts?
You can use the chat, or you can jump in.
Yeah, chat works too if you don't want to speak up. Assuming I can figure out how to find the message.
Yes.
The exterior walls.
Yeah, yeah, exterior walls. Anything else?
The enclosure of a conditioned space.
Say again. Sorry, I had a hard time hearing you.
The enclosure of a conditioned space.
Yeah, yeah. So that's a pretty general way to put it for sure. So we're talking about right, what separates conditioned from unconditioned space, and I guess yeah, that's probably the best way to sum it up into just one sentence. I saw a message come in, layers of the walls.
It's more than a layer. The walls, yeah. Sorry.
Yeah, so layers of the walls. Yeah, definitely. So, um, and we're also not just talking about walls too. So we're talking about windows. We're talking about roof systems. We're talking about foundations. Um, in some cases, you might have in a commercial building, you might have a garage, a garage space below a conditioned space, and so you've got a slab and a garage ceiling that has to have a defined boundary from heated space above and unconditioned space below. Uh, so we're talking about all of these components, and it looks like Olivia mentioned layers of the walls through the chat. So let's talk about those a little bit. What kind of what kind of layers might we mean? I mean, so obviously we want to try to keep heat out. We want to try to keep, or excuse me, keep heat in. We want to try to keep the air in, which carries heat, obviously, and we want to try to keep bulk water out, right? So really, uh, we're really talking about those control layers, which are our air barrier, our thermal barrier, vapor barrier, and a drainage plane, or you might hear the term bulk water barrier. Basically, that last one basically just meaning liquid water. We want to keep that out of the building, right? That's probably the number one enemy of any building envelope is bulk water getting into the building, or water is vapor condensing in the building somewhere and causing durability issues. Doesn't matter how efficient your envelope is if it's not going to stand the test of time, it doesn't matter. So these last two, vapor barrier, bulk water barrier, and drainage plane, and to some extent, in many ways, the air barrier and what the air barrier is comprised of. Those three things really play a huge role in building durability, specifically water. So when we say envelope, this is kind of what we're talking about. We're talking about these layers here. And that, again, those layers apply to, but like we said, the walls, the roofs, the windows, the foundations. And one thing I hadn't mentioned yet is, the interface of these different locations. So where a wall meets a roof, or where a wall meets a window opening, or a wall meets a foundation, those transition points, where system A connects to system B, those are probably the most critical transitions in terms of efficiency and durability of the building, because it's not just one material, it's several materials having to come together and integrate in a way that keeps these control layers continuous as we transition, like we said, for example, as we transition from a wall to a roof. So that's what we're talking about when we say envelope, at a very high level. And so when we talk about envelope commissioning, that term commissioning, what does that mean to anyone? Or, take a wild guess. There's no bad answers here. But what might you think we mean by commissioning?
Good question.
Yeah. Well, and it's kind of an unfair question because I already asked if anyone had heard of it, and everyone said no. So I'm not expecting a lot of answers. So maybe I'll get into it here. So when we say commissioning, what we're really talking about is it's really an independent set of eyes on the building envelope. In my case, the building envelope, usually for the building owner. So building owners, architects, and the engineers, they've got a lot on their plate as it is, from design all the way through end construction of a project. There's so much for them to track, so much paperwork to process, and so much to be involved in, just in the general day-to-day happenings of a design phase or construction phase of a project. So they really don't have a lot of time to focus on, some of these really critical aspects of a building, such as the building envelope. And so more often than not, or I should say lately anyway, what is becoming more and more prevalent in commercial construction is envelope commissioning, this independent set of eyes, sort of to look at the building envelope for the owner or for the architect, to try to really help them assure that the envelope they're designing and the envelope that's being built is up to par. We want to make sure that not only is the envelope being designed to perform to the owner's whatever the performance goals are that the owner has, but we want to make sure the workmanship is there too, so that we know that the quality of the build meets the intent of the design. And so another way to look at it is you could call it a quality assurance process. Your sort of QA for the building design and for the building construction. And so as an envelope commissioning agent, and by the way, I should mention, if you didn't pick up on this, BECX, that's just an acronym short for building envelope commissioning, CX meaning commissioning. You'll see this a lot. You'll see CX or BECX out there. That's what that's short for, is commissioning or building envelope commissioning. So, and as a building envelope commissioning agent, it's important that, it's important to remember that, I don't have my architectural license. I'm not a licensed engineer either. I'm not stamping any drawings. When this building gets approved for construction, it's not my stamp. It's not my architectural stamp on these drawings. So in other words, I'm not the one that has the liability here. So what that translates to in the field as it relates to my role is, we should be regarded as, and we should be treating the process as if we are just a consultant or an advisor. We're not an authority figure. So if I see something that I don't like during this commissioning process, I don't necessarily have the authority to say, you architect, you have to change this, or builder, you have to change this. I can only make recommendations and call out any discrepancies. And when I say discrepancy, I mean something that in construction that perhaps deviates from what the design shows. So I can only call those things out and make my best recommendation. I can't, because I'm not stamping anything, I have no authority to say what can or cannot happen on the job site. And sometimes certain jobs, you're regarded more as an authority figure, even though you shouldn't be. And a lot of that has to do with just sort of lack of understanding of how our position really works. So we're really just a consultant. Let's see. So why have envelope commissioning on a project? We talked about this a little bit already. We're there to help. We're really there to help ensure that the building efficiency, durability, and sustainability, those three things are, we're optimizing those as best we can. And we're doing that in both the design phase and the construction phases, which we'll get into in a little bit. If we can help facilitate a better envelope through design and through construction, it could mean, depending on how much we can gain through that process, it could mean that we can actually help the owner reduce their HVAC system size. So in other words, if we can make a more efficient envelope, the mechanical equipment will have to work, in theory, shouldn't have to work as hard to maintain that environmental condition that we're trying to maintain in the space. And HVAC equipments on commercial projects can be very, very expensive. So if we can do anything to reduce the size or the amount of mechanical equipment that's needed, there could be a huge cost savings there for the owner. And it's important to mention too, obviously we don't work for free. So, to commission a project, obviously there's a premium there for that. There's a cost. So the reality is, if you look at a total project cost, say we're working on a $20 million project, the total project cost is $20 million. Our commissioning effort is just a fraction of that. So it may be, I'm just pulling numbers out of the air here, but let's say, $30,000 for a commissioning effort wouldn't be unreasonable for a building that size or of that price point. So $30,000 of a $20 million project is actually a pretty small fee if you think about it. And it might be more and it might be less than that, but you get the idea, which is that it's the added cost is really not that significant when you look at the grand scheme of an entire project. So to have that extra service, that extra set of eyes on the envelope through design and through construction, really oftentimes has a pretty favorable payback. The things you find in design and the things we find in construction, usually you can offset the costs of our commissioning services just on the areas in which you improve the building envelope. Now that said, that is highly dependent on having a project team that's on board with what you're doing. And so what I mean by that is, so when I say project team, I mean owner, I mean architect, I mean builder, or construction management firm, as well as ourselves, the commissioning agent. So if you don't have all of those players aimed or with their eyes set on trying to make the best envelope they can design or they can build, oftentimes things get dropped. So for instance, design phase, we may make a bunch of comments about an architect's design for the envelope, but if they're not necessarily buying into how we can be of value to them, they may ignore most of our review comments and nothing may happen with that design. The design may not get improved all that significantly from where it was. And so as long as I, the commissioning agent, is doing my part to sort of lay out our recommendations, again, I'm not an authority figure, that's about all I can do. So it's really up to the architect and the owner and the builder to use or not use the advice we have, and that sort of dictates whether or not the cost of our services is really offset by any gains in envelope improvement. So oh, and I forgot about this last item I just put on the screen, excuse me. So some building codes are actually starting to require envelope commissioning. When I started at a company that, like I said, since got bought out, back in 2012, when I started, envelope commissioning was barely on anyone's radar in the commercial industry. In fact, the reason, so I started in 2012 as an intern, and my boss had intended me to be hired full time, after a 6 or 7 month period. But envelope commissioning was so sparse at the time that by the time I got to the end of that internship period, that just the work wasn't there. So he had to let me go for a year. And then about a year later, things really started picking up again. And from then on, commissioning has just slowly been ramping up in terms of projects that are requiring it, and now building codes starting to incorporate it into their base code. So the state of Vermont, for instance, as of this last September, they've just started to require that envelope commissioning is incorporated into any commercial project. So any commercial building has to incorporate, any new construction commercial building now has to incorporate either envelope commissioning, or they have to go through a blower door test at the end of a project. We'll talk about blower door testing in a little bit, but most so far, there haven't been many projects under the new code yet, but most so far have been choosing the envelope commissioning route. But the point is it's starting to show up in building codes, and I suspect that'll only continue in other states as well. So I talked about this a little bit, but you know, when does building envelope commissioning take place? I mean, we can sort of break it into three main parts of a project. You know, design phase, construction phase, and what I call the post envelope or the occupancy phase of the building. So these are pretty straightforward. Design phase, obviously, this is when the design is being fleshed out. Construction phase when it's being built, and then post envelope or occupancy is obviously when the building is wrapped up and about to be occupied or is already occupied. Certainly you could break these phases down further. You know, design phase, we could consider, you know, design phase to also include pre-design, schematic design, design development, so on and so forth. But by and large, we're, you know, all of what we do, you know, we have pieces of our services that fall in each of those categories, but we'll just call, to keep it simple, we'll just call this the design phase. And I'm not going to go through every one of these items listed beneath each of these phases, but it will give you a sense. I'll give you a second to just kind of look through those. These are the types of, you know, the types of things we might get into in each of these phases. The ones I have highlighted in red, we'll get into in a little bit more detail. Those are the ones that, in my opinion, bring probably the most value to the owner and just to the project as a whole. And I think these are the ones, for purposes of the presentation today, that are probably the most tangible in terms of sort of grasping the understanding of what we're doing. Excuse me. Any questions? I should take a break here for just a second to just ask if there's any questions about it thus far. What I'm going to do here is I'm going to kind of get into each of these phases a little bit, show some examples of you know, real world examples of what I might be doing in each of these phases. But just up until this point, are there any questions?
Well, I have a question, just a clarification.
Yep.
Your client is the building owner. You don't work for the architect, or you don't work for the construction company.
That's a great question. So 9 times out of 10, it's the owner. Yes. There are occasions where we can be hired by the architect or by the construction management firm. But usually it's the owner. You know, getting hired by the construction management firm is not very common. You know, most construction management firms, if they can avoid, to put it bluntly, if they can avoid additional work and responsibility, they will, because they're on a budget, they're on a schedule, and anything that might threaten that budget or that schedule, you know, is just going to be a hindrance to them. So usually it's when we'll find we get hired by construction management firms when that firm in particular has sort of set a company goal or policy to put out the best, you know, the best products that they can. There are a couple of firms out there that are doing that, most of them in the Vermont region. To name a few, ARCH Construction Company, HP Cummings. There's a smaller firm, actually they're growing quite a bit, but Negley and Chase. all of these firms, they're construction management firms, but they've dedicated themselves sort of to the cause, so to speak. And so it's in those instances where they might say, hey, we want someone, the project's not requiring commissioning, but we want someone there to help us ensure that we're giving the owner a good product. And so sometimes that'll happen. And the commissioning process then is very different in some ways, because when the project doesn't require it and you work directly for a construction management firm, they can kind of dictate what you do and don't review, and they may, you're only responsible for reporting to them, and it's up to them to do what they want with the information given. So you don't have the obligation of going to the owner or going to the architect with anything you've learned. Whereas when you work for the owner, which, like I said, 9 times out of 10, we are working for the owner. Obviously, the owner is always going to want any information, especially if it's information that is in interest of helping the building envelope along. They're going to want that to be known by all parties. Whereas construction management firm might sort of throttle some of that and dictate, sort of act as a gatekeeper for which information they act on versus which information they don't. So it can be a different dynamic. But in short, yeah, most of the time we're working for the owner. There are exceptions where we may work for the architect or the construction management firm. That's a great question.
In this kind of building commissioning, things might change. I mean, if the construction company has to prove that the building or meets the requirements of the code, maybe they can start hiring these kind of companies before, especially if they want to sell dwellings to clients or to other clients, and they have to show a certificate that it meets a certain requirement. So the market can change. I mean,
Yes, no, absolutely. That's a great point. So for instance, like I mentioned, Vermont, you can either take there's 2 paths to compliance with this air barrier commissioning. You can either have construction phase commissioning take place, or you can say, we're not going to commission, but we're going to meet a blower door test requirement, which is a quantifiable test. And so even though they may not want to check off all of the items on the commissioning checklist through the code, they may say, we're going to take the blower door path, but they may still hire us for certain pieces of commissioning in order to help them ensure they get that blower door target that's listed in the code. So we may start to see some of that. We very well could. Like I said, that code in Vermont only just came through in September, so we haven't run into a whole lot of projects yet that are getting their construction permit after September, but they're starting to roll in now. So yes, we may see this shift toward more and more construction management firms taking this on to help them ensure they're getting a good product. So let's take a closer look at design phase here, and specifically some design review scope. So this is probably one of the biggest things, or the most beneficial services we can offer as a commissioning agent in the design phase of a project. So, probably somewhere around design development, we'll start to get progress drawings sent to us by the architect, and they'll say, hey, this set is, we just issued this set. We'd like your review of it, and we'd like your comments, if any. And so we'll pick that set of drawings up and we'll go through them, and we'll look at those things we talked about at the beginning. We'll look at the building envelope layers. We'll look at the air barrier, the thermal barrier, the drainage plane or bulk water barrier, and the vapor barrier. So we'll start looking at all of those things for the walls, the roof, the windows, foundations, so on and so forth. So this is where we start to get into the design of the building and say, what do we have here in regards to those items? And we really want to make sure we're getting this design right, because what you get for a finished product, you know, can only be as good as the design, right? So if you don't optimize the design, you know, the construction could be perfect, but you might still have a lousy envelope. So this is really the place to start, and this is probably where we offer the most value in the design phase. Is this review? So let me just skip ahead a slide, make sure I'm not leaving anything out. Nope. So let's take a look at this this wall assembly here. There's a couple of different views that's being shown in. There's a lower view, an upper view, and a plan view. Essentially, this lower and upper are cut through in section. Actually, that, oops, sorry. Actually, the upper almost looks like it's cut through in plan because you can see a stud here. And obviously the plan view is cut through horizontally in plan. But essentially it's the same envelope. It's just either cut in section or in plan view. We can just assume they're all in plan view. That's fine. I'll walk you through these layers here. And this is just an exercise. If you've got a feel for things and wanna call out your thoughts, feel free. But let's look at this. So just going off of all of these ledgers here, going from the outside of the assembly in. So we've got our exterior cladding, right? They don't show this pressure treated PT, pressure treated strapping, but that's what this space represents, this white space here. There's probably a 3/4 inch strapping that the cladding is fastened to. And then behind that strapping, there is a building wrap. And we'll get into what each of these layers might mean in a second. 2 inches of rigid insulation with taped seams right here, this sort of grid, this you know, thicker grid hatching. They don't tell us what type of rigid insulation, but you know, we can maybe make some assumptions based on the R value. So it's R11.4 at 2 inches. So you know, XPS is about R5 per inch. So this is a little bit more significant than that at 2 inches. You know, XPS would be R10. So we might be dealing with a polyisocyanurate, probably foil faced, would be my best guess without specifications to tell us right now. That would put us at about this R value. So let's assume a foil faced insulation. And then we have an air barrier over half inch exterior sheathing. Then our fiberglass insulation in between our studs, and then a vapor barrier, this black dashed line here, and then our finished drywall. So I'm trying to think of how to pose the question here. There's something in this assembly I don't like right off the bat. If I were to review this wall assembly, from a durability standpoint, there's something in here that I would right off the bat make a comment on, and it has to do with vapor barrier. Not necessarily just the vapor barrier that's called out, but the vapor barrier strategy as a whole. Is anyone picking up on anything along those lines? I'll take some time to sort of look this through.
I have a question about like the structure. How do you attach the strapping if there's insulation right behind it?
So good question. That's a great question. So right, so there's strapping here. Let's just picture there's strapping here. What they'll do, because obviously if you try to zip a fastener through right here, can you actually, by the way, can you see my cursor as I move it? Or is that, you can, okay, good. So really what has to happen is if you want that to be structurally sound, they're going to put up their strapping, and the strapping is going to run, assuming this is horizontally, you know, oriented cladding, like, you know, just typical clapboard siding or something, the strapping has to go vertically. And so what's going to happen is they're going to put that strapping, they're going to land that right over each of their studs. So there'd be a piece of strapping right here. So to make that structurally sound, they'll put a fastener in from here all the way through the insulation until they grab that stud. If they put a piece of strapping here and they go all the way through, they'll catch a little bit of sheathing, but that insulation is probably not going to be very structural. And so if they're not grabbing studs with their fastener, yeah, you're probably going to have, your cladding's probably going to fall off the wall. So typically they'll align that strapping right with the studs, if that makes sense. Great. So coming back to the vapor barrier question, anyone pick up on anything there?
When you want it closer to the exterior?
You could have it closer to the exterior. So there's a lot of things going on here. I would have been very impressed if anyone nailed this. So I'll get into it just for sake of time. So obviously we've got a vapor barrier here. And I'll address, I'm not sure who just chimed in, but I hope to address your question in a sort of roundabout way here, and let me know if I don't. But so we have a vapor barrier here, and in a traditional sense, if we were dealing with just a simple fiberglass batt wall, insulated wall with just siding right over sheathing, that would be a pretty conventional residential system, right? But we have one here, and that's not necessarily a bad thing. And when they say vapor barrier, I'm assuming at this point it's a true barrier, right? So this is probably something with really low permeability, meaning vapor is not really going to pass through this in any way, shape, or form. So this is kind of a barrier. The thing that caught my eye after seeing this, is this rigid insulation. So the rigid insulation is our thermal barrier, but it has properties to it that make it act very much like a vapor barrier as well. So remember how I mentioned this, we'll assume this is a foil-faced polyiso insulation. The foil facing on a polyiso insulation, I mean, it's foil, right? So if you ever looked at some Reynolds wrap, tin foil, but water as vapor is not going to move through that. So this is very much the same thing on this insulation. So if this is a foil faced insulation here, and we have a vapor barrier here, what do we have going on? We've got a double vapor barrier, right? So double vapor barriers are kind of a no-no, or they're a big no-no really, because if we, for whatever reason, during construction, if we trap moisture, either during construction or if there's a leak post-construction, a water leak into this assembly between these two layers, if we get moisture in there, it's totally trapped, right? Because we've got a barrier here and a barrier here, here. If we get water of any form in here, it's trapped and it's got nowhere to dry. So all it's going to do is it's either going to saturate this insulation, or if it's bad enough, it could get into these studs and start rotting those studs out slowly over time. So there's a double vapor barrier situation here, which is the first thing that catches my eye. Even though they're not identifying the insulation as a vapor barrier, we have to be thinking about the properties of all these materials and how the thermal barrier in this case, or part of the thermal barrier, because there's also batt insulation here, which is part of the total package for the thermal barrier. But part of the thermal barrier out here as our continuous insulation, we have to think about how that sort of affects the whole wall assembly, not just from a thermal standpoint, not just from an R value standpoint, but also from a vapor drive and durability standpoint. So that's what's catching my eye. And so the question was, well, is this vapor barrier too far inward? There's a couple of ways we can approach what we should do with this vapor barrier. Do we leave it? Do we move it out, or what do we do? we didn't talk about this air barrier and what it is. This air barrier could be, it could have some properties that are inherently vapor open or vapor closed. And so it too could be acting like a vapor barrier for all we know. I'm going to sort of gloss over that for now, and we'll just stay focused on this insulation and this other vapor barrier. But so again, the question was, what do we do with this layer here? I keep clicking and it keeps moving on me. So there's a couple things we could do. We could say, well, what happens if we just get rid of it? We know we've got an inherent vapor barrier in the continuous insulation out here. So is that okay if we just delete this and just call this sort of an inherent vapor barrier? And that might be okay. The thing we have to consider in that case is our dew point at this point. So if we're saying we're going to eliminate this vapor barrier, it's basically implying we're going to let vapor in further into our wall assembly, right? And so as we do that, obviously as we go from heated space over here to cold space over here, as heat and as heat moves through this assembly, it's going to start dropping in temperature. And so where's that dew point, right? And of course the layer we may be concerned about being below dew point is probably this sheathing. That's kind of the first condensing surface that vapor is going to hit, in the wall assembly as it goes from inside to out. So we have to assess, what do we think about the dew point here? And there are some calculations you can do to actually calculate that dew point and whether the sheathing layer is above or below it. I won't get into that right now, but there's some general rules of thumb out there for our climate zone. Keene area is actually in a climate zone 5. The rest of New Hampshire is climate zone 6. But if we pretend we're in climate zone 6 right now, the general rule of thumb is you want 50% of your R value to be on the exterior and 50% in between your studs. If you're going to have a hybrid assembly, meaning some of your insulation on the inside, some of your insulation on the outside. So if you're going to break up where your R value is, the general rule of thumb is 50% here on the exterior versus 50% inside. And so the reason for that is if we're putting a vapor barrier like product or insulation over our sheathing, we want to make sure there's enough R value there that this sheathing is still staying warm even with all of this R value on the inside. So if I'm looking at this, R11.4 on the exterior rigid insulation and R21 between the studs, that's not a 50-50 balance, right? If it were 50-50, we should see more like, what's that total? 32 and change. So we should see more like R16 here and R16 here. So you could delete this layer and either increase the thickness here of your insulation to get that 50-50 balance, or decrease it on this side. Of course, you've got to make sure you're still meeting code minimum requirements. But in a nutshell, you could increase one side or decrease the other and eliminate this vapor barrier. The other thing you could do is you could say, well, maybe it's okay to have two vapor barrier products as long as one of them has more breathability. And so they make a product out there called a smart vapor barrier or smart vapor retarder that actually allows the vapor barrier to become more vapor open as humidity levels or as vapor levels increase. And then it becomes more vapor closed as those levels decrease. So if you had moisture within your wall cavity here, this product would be more prone to opening up to allow it to dry out in one direction. So I'm not sure who asked that question, but and I know that was a super complicated answer, but the takeaway is here is that vapor barrier, you could move it, but you really have to be thinking about how all of the other components of the envelope assembly play into that. And so in this case, in this example, those are probably the two options I would have explored: adjusting the ratio of R value, or if we're not touching the R value, we change this product to be something that can become more vapor open if we need it to be. How am I doing on time? 9:50. So let's look at one more example. Let's look at air barrier instead of vapor barrier at this point. So when I'm looking at air barriers, especially as they relate to thermal barriers, there's these three items here you'll see. We want the continuity. Obviously, we want these barriers to be continuous, right? So earlier I mentioned wall to roof transitions as an example of a transitional detail where two material types have to interface and be continuous with one another. So here's an example on the right. This is a wall to roof transition, and this roof has a big parapet right at the end. So continuity of our air barrier and our thermal barrier is important, meaning if our air barrier is coming up the wall, we want it to, in some form or another, be continuous across to our roof air barrier. And same with the thermal barrier. We want this insulation to be continuous across to our roof thermal barrier. And the other thing is alignment of the control layers. So let's talk about that a second. So I've got these colored lines on this detail to help better visualize things. So in this particular detail, the roof membrane, we're going to pretend the roof membrane is what they're calling the air barrier. So not only is it sort of the finished membrane of the roof, but it's also going to serve as the air barrier for this example. So and our wall air barrier will be on this layer of sheathing here. So just to draw it as a single line, this red dashed line indicates the path of our air barrier. So it's going up the wall, all the way up the sheathing of the parapet, and it's wrapping around, and somewhere in here it's probably connecting with the roof membrane, which then carries down the back and across the roof. So there's at a high level, that's the path of our air barrier. And our thermal barrier is in blue. This comes up, and yes, the insulation carries up past, along this parapet, but the actual insulation for the roof is down here. So really our path of continuity is this way in terms of the wall to roof transition. So as we look at that, what would you say? Would you say the air barrier in red and the blue and the thermal barrier in blue, would you say those are in alignment with each other or not?
What is this black stuff? The mineral?
Yeah, good question. So I left that out. That's supposed to be a mineral wool insulation, I believe. So for all intents and purposes, I think we can consider this R value right here of some form. And so I think we've got this continuity of the thermal barrier through here. So yeah, in terms of these two different systems being in alignment, meaning they follow the same path. Do they follow the same path or do they not?
They don't.
They don't, right? Yeah. So the thermal barrier is following this path, and we're sending our air barrier all the way around this parapet. So there's a couple of risks there. If we're saying our air barrier is way out here, we're basically saying our indoor conditioned air can be contained right in this space. And it would still be within the air barrier, but it's beyond our thermal barrier, right? So when we're out of alignment like that, what can happen is, notice while this side of the sheathing has R value on the parapet, the top and the back side of the parapet have nothing. So all of this square you see here is actually a piece of tube steel, and then it's represented by these vertical lines as well. So all this steel here is going to be pretty cold because there's no R value on it. So if we're saying warm air from here can get through and hang out in this space, because again, our air barrier's around the outside of the parapet. So if we're saying warm air can get here to this cold space, what do we think is going to happen? Yeah, you're going to get right. There's a high chance of condensation there. And I'll skip ahead an image here. So this is actually a real life detail we tested. And mind you, the roof, so what you're looking at is roof membrane here. It's a little bit of a hard angle, but to the left side of this image is the roof, right? So here's this white roof membrane coming up, and it's coming up the parapet. You're essentially looking straight down this, straight down this parapet here along the length of it. So the roof membrane's coming up, and you're looking at it, sort of a flap of it right here at the top. That's what this is. So obviously it's not tied down onto our layer of sheathing here yet, but we wanted to prove the point. Can air really get past all of this, all this wood and this insulation? Can it really do that? So we weren't really concerned about air getting in here or getting out. It was more just to say, can it just get to here? So to do that, we kind of had to have this roof membrane open. And so we had a guy actually put some theatrical fog right into this zone below the thermal barrier transition. And sure enough, you can see this kind of haze here. It's hard to see, but there's a haze. That's actually fog having gotten through here all the way up and out. So it kind of proved that, yes, we can get air here. And if we know this is going to be cold space, there's a good chance there's probably going to be condensation there. So, yeah, that's another example of something we're looking for as we look at these transition details, is alignment of these materials. So, those are just two examples of something, in the design phase or in our design reviews that we might pick up on. And that's just two of dozens and dozens, if not hundreds of different, types of situations you might find when you're looking through a set of drawings. Let's get into construction phase a bit. I'm getting a little, I want to keep things moving here. So I want to talk about, you saw I sort of took off this kickoff, kind of fades out of the picture here. And then you're left with these three items for construction phase, mock-up review and testing, inspections and field reports, and quality assurance testing. So let's look at a couple of examples. So I want to talk about just general construction phase testing. So on most projects where we're commissioning, testing the installations is a huge part of the commissioning process during construction phase. So we're at a point now where the design is complete, the building is being built, right? It's in active construction. So testing is important because it can identify one of two things, or one of three things, I guess. So if you test an assembly, let's say we're testing a window installation for air and water tightness. That's the example we're going to look at. If we're testing a window assembly to make sure that it's airtight and that it's watertight, if we have no issues and it passes the tests that we employ, then it tells us that the installation procedure, both design and workmanship, are working. If it fails one of those tests, if it leaks more air than is allowed, or if there's water penetration to the interior, it can, depending on the nature of that failure, it can tell us one of two things. It can tell us that either the workmanship isn't up to par with the design, or it can help us identify a design issue that wasn't caught back in design phase. So testing is really important for that reason, because again, even if we perfect the design, a system might not perform because the workmanship was bad. Or the workmanship could be exactly as it was designed, but there may have been an oversight in design that was really important to catch in construction phase by doing this testing. So let's look at an example here. I'll explain this a little bit, and then I'll move ahead to some photos to give you more context. But here's this is a real world example. We ran into this last summer. What you're looking at is a storefront sill. So here's the base, or here's the wall system coming up. So there's some exterior brick, there's an airspace, exterior insulation, sheathing, and then this is your interior framing, framed wall. And then sitting on that is here's the frame of your storefront coming in. So it's cut through in section, and you're looking at this frame. And then so the transition, part of what we're testing, so we tested this assembly for air tightness and for water tightness. We wanted to make sure that the storefront unit itself was airtight, meaning it's tighter, or just as tight as or tighter than what the manufacturer of that unit says it is what it's rated to handle for air leakage. So we wanted to test the unit itself, and then we also wanted to test the unit and this transition from wall to storefront. So basically test these sealants for water penetration, for the same reasons, to make sure that it all is within the manufacturer's specifications. And so I'll skip ahead a bit. We did that, and as part of an air tightness test, what you'll see here is on the inside of this wall. So here's that framed wall that that was shown right here in the drawing. Here's that framed wall. On the inside, around the window unit, we built this enclosure, right? And so we're depressurizing that with a vacuum or this fan to create, for the air test, to create a pressure. And so as part of this test, there's a meter hooked up, and once you reach a certain pressure under this enclosure, you should be able to take a reading on a meter here, and either the air leakage is above or it's going to be below the acceptable threshold for air leakage of this specific unit that we're testing. So of course you're going to have some leakage through the enclosure itself, because our taping of this enclosure to the window is not going to be perfect. So without going into all the detail of the test, you get two numbers, and part of it, one of your numbers, is actually when you mask the tested unit from the outside as well. But one thing that was really concerning is when we depressurized our unit from the inside and put this plastic up on the outside, look at what this plastic's doing. It's getting pulled right into right against the outside of the window itself. So that might tell us that we're actually pulling air through the unit from the inside, from the outside all the way to the inside. We've kind of capped this window on two sides with an enclosure. And in theory, if the window unit was completely airtight, this plastic you see from the exterior here, really it should just be sort of laying loose, because the unit behind it should be totally airtight, but it wasn't. So it told us, in fact, I think this is a video. You can see when we took that plastic off. You probably can't hear that audio, I realized, but as it's going through, what's going to happen here is the chamber is running on the inside. We're drawing negative pressure. So let me pause it a sec. So this fan is pulling air out of the enclosure. So from the outside, what Quinn in this video, what he's doing is he's taking this little fog pen and he's helping to identify where we're pulling that air in from the exterior. Where is it getting around this window system to the inside? So I'll play this through, and you should see here this fog getting pulled in a couple of spots here in a moment. So see that right there. Notice how it wasn't traveling off to the side. And it's kind of just getting pulled right in. See that? So that fog pen, it looks like it's really just pushing it in there, but it's really not coming out that heavily. So I'll play that again while I'm speaking. So you'll see it kind of got pulled into this joint right beneath the windowsill. Forward on that again. Right between the window frame and this little piece of metal that comes out beneath it. So I'm going to go back. So that joint that it was getting pulled in is right through here. Right here. And ultimately, when we did a water penetration test, it's hard to see here. Very similar enclosure on the inside to introduce pressure, but instead on the outside, we're spraying water at the unit. And so what happened is on the inside, under that pressure, water actually came pouring in right between the frame of the unit and this thing called a receiver that the unit sits in. And so I'll go back to the detail here. That's this joint right here that water was coming in. And so this, between those two tests, we actually, we could sort of identify the path of travel for air was through here, as we saw with the fog, and ultimately all the way up through here. So that was our total path. And so ultimately those two tests were failures, both for air leakage and for water, because water spilled into the interior and we had so much leakage that it was way above what was allowed for that test. So what do we think? From what I could tell, the builder built it right. So do we have a construction issue or design issue here?
I have a quick question.
Yeah.
When doing the air test, do you treat the window as the same way you would do like a blower door for like 50 Pascal, right around that?
So yeah, good question. So in terms of pressure, usually not. So what happens is, and there's a huge rabbit hole you could go down here, but ultimately what happens is when a manufacturer builds a window or a storefront or a curtain wall system, most of them go through a laboratory test. They test it for a bunch of things: air leakage, wind load, deflection, air leakage, wind load deflection, water leakage, structural endurance, so on and so forth. They test these things in the lab, and so basically what comes out of that laboratory testing is sort of the maximum rating at which the window or storefront or curtain wall can withstand each of these types of tests. So for air leakage, for example, different windows have different what they call performance classifications. So what they'll do is when they come out of the laboratory test, they'll classify it as a certain grade or a certain type of window. And basically they'll assign it the pressure it was most capable of handling. And then assign the air leakage at that pressure. So for instance, this unit that we tested, if I remember right, it was in the laboratory, I want to say allowed, or it was rated at 10 pounds per square foot, which in terms of pascals translates to about 480 pascals. So it's a much, much higher than that 50 pascals you might do with a blower door test. But it was tested and it exhibited a certain level of air leakage at that pressure. So they set a threshold for the air leakage to say, we don't want our system to exceed this much air leakage. And so they go up to the pressure in which it can withstand before it exceeds that air leakage. And so in this particular case, it went all the way up to this 480 pascals before it crossed that threshold. So that's how they base the pressure for this window unit. In the field, you're allowed to derate that a little bit because there's some field conditions. A laboratory test happens under perfect conditions. It's all very controlled, and in the field it's less so. But long story short is the pressure is totally determined by the manufacturer and what that unit is rated to withstand. So it might not necessarily be 50 pascals, and usually it's much higher, if that makes sense. So coming back to this, really we're really dealing with a design issue here, and it's something I missed when I reviewed this in design. I actually thought this little transition right here, for whatever reason, I was thinking that was a continuous or a solid joint, meaning it didn't have an opening. So I thought we didn't have a pathway all the way through, and same with right here. I thought this was all continuous and closed, but in construction, we found that these joints were actually wide open. I'm going to move on from that for sake of time. I'll give you one more example of construction phase testing. And before I get into this one thing I didn't mention is mock-ups. So oftentimes before, sort of between the design phase and the actual construction of the building itself, a lot of projects will require a mock-up be built. So, which is usually just a miniature version of the building that captures many of the critical details of the building envelope and the way it's going to look. I'll go back a bunch of slides here to show you an example of that. Right here. So here's an example of that, right? So it's just a snapshot of parts of the building where, here they said, let's put up a wall and let's punch an opening through it so that we can accommodate a window installation. The window's not installed yet, so we were just there to fog test some of these details for airtightness. But eventually a window would go here and there'd be some curtain wall glass going in where you see all this insulation down here. But this is the idea behind a mock-up is you build something in advance of the building itself so that you can test your assemblies here, and if you fail here, it's okay. If you fail those tests here, it's okay, because this is exactly what a mock-up is meant for, is to learn from the faults, whether it's a design issue or a construction issue. If something goes wrong on your mock-up tests, that's the place to learn, because you don't have to worry about the cost of tearing something out to fix it because it's not on the actual building. So mock-ups are a great way to sort of vet a certain design or the workmanship of the constructed product before they go and take those details and apply them to the building itself. So things that are learned here when you're testing a mock-up, be it a window for air or water penetration, or be it air leakage for the air barrier assembly, anything you learn there, you can take those lessons learned and apply them to the building itself. So mock-ups are really handy for that, and I glazed over that earlier, but I did want to mention it. Just getting back to the next example. So I just mentioned fog testing, and I've mentioned it a couple times. So one way we can sort of check the air barrier itself at transitions for air tightness, to ensure that, a wall transitioning to a foundation or a wall transitioning to a curtain wall, which is what we're testing in this example here. So testing that air barrier transition for air tightness can be done with this pretty crude test approach called fog testing, or first instance testing. So we're testing the first instance of this wall air barrier to curtain wall rough opening transition to see if it's airtight or not. So what he's doing in this photo is he's just taking, it's essentially a shop vac with a fog machine inside of it, and he's blowing this fog at this detail. So this is the jamb of a curtain wall where it meets a framed wall, and on the other side is the air barrier that's coming across this wall and tying into the curtain wall assembly. So there's usually a bead of sealant that connects the two from the curtain wall frame to the air barrier of the wall. So he's testing this joint at the rough opening to see if air, really all we're checking is to see if air gets through to the exterior or if it doesn't. And obviously the idea is we don't want it to get through. So it's a simple test. One guy stands on the inside, the other guy goes on the outside and looks for leaks. The idea is not to quantify the leakage, but it's just to identify, one, does it leak? And two, if it does, how bad is that leakage and where is it and what can we do about it? What's the shortcoming? Is it a design issue or is it a workmanship issue? So it's just a qualitative test. And the idea behind doing this is oftentimes buildings will have an air tightness target set at the end of the job. So someone mentioned blower door testing. A lot of projects will specify blower door testing and they'll set some really ambitious air tightness goals. And the only way you can really sort of help facilitate the air barrier reaching that goal is visual inspections is one thing, but you can only see so much with visual inspections. So the other tool we have is this fog. So it doesn't quantify anything for us during construction, but it can really help us identify where our issues are. And similar to the mock-up that we talked about, these tests here, anything we identify here about this detail, we can apply those lessons to other locations on the building as they get constructed. And that's why we try to test these types of details when they first go together rather than when they're all complete everywhere in the building, because it's more of a pain to go back and test retroactively versus being proactive about a detail. So this testing is really to help facilitate the project reaching a certain air tightness goal that'll be verified at the end by blower door testing. Because once you're at the blower door test, a lot of your air barrier components are completely covered up by finished materials. And so getting to them is a real problem at that point. And to do something about it is much more difficult. One last example I want to give you, and this relates to this fog testing, is so we tested a wall to foundation transition a few months ago. We don't have to worry about most of these layers here. I'll just tell you that this sheathing is the air barrier. It's a zip sheathing product. I'm sure most of you have probably at least heard of that zip sheathing. It's the sheathing with the green membrane over it that sort of acts as a inherent air and weather barrier. So the transition to get that air barrier onto the foundation, so the foundation itself, the concrete, is serving as the air barrier for the foundation wall. So we've got to connect zip sheathing on our framed wall to the concrete foundation. And to do that, they specified a product made by the Huber, the zip sheathing company, called Liquid Flash, which is really conventionally tapes are used to go from this one material to the other, especially where there's a jog in the transition like this. But there's a product that's coming out or has been out for a little while now called Liquid Flash, where it's basically a liquid membrane tape, if you will. It's just a liquid membrane that transitions across and down and cures to all these surfaces. So we tested this joint. They had put the Liquid Flash in as it's drawn here, and then we applied fog from here. The insulation wasn't in yet, so we were really putting fog right in the wall cavity here to see if it leaks out and around this wall to foundation transition. Because again, we want wall to foundation to be airtight because we're changing air barrier approaches here. So here's that detail in reality. They actually ended up, you can see here, so this is the zip sheathing we were looking at, and then here's the foundation below. I forgot, they actually ended up using the tape on the sort of this jog here and this underside. And then I think they went to that liquid flash from here and down onto the face, which is fine, as long as the liquid flash and the tape overlap. But here's that detail we were looking at in that drawing. And here's looking sort of up underneath. You can see this is the foundation wall, and this is where we saw that zip sheathing sort of extending out a little bit. Here's an even better view over here. So you can see this haze here. That tape came across, and we were supposed to have liquid flash come across and down onto the foundation, right? But look at this haze. That's fog leaking through as we tested from the inside. And in fact, right here, you can actually see there's exposed wood. That's the wood plate. So what do we think about this detail? Do we think we have a workmanship issue or a design issue? Did the builder build it as it was drawn, or not?
Is it a workmanship issue?
Yeah, it's a workmanship issue, right? So if we go back to the detail clearly shows if this is our air barrier sheathing, and this is what's transitioning us from our zip sheathing air barrier on the wall to our concrete air barrier at the foundation. If I look at this detail, this is all continuous, right? So we've got membrane touching concrete, carries it across the underside, all as one solid line, carries it up the zip sheathing, and grabs the zip sheathing. So it's all continuous here from a design standpoint. So to see this fog come out and to see that liquid membrane didn't actually come all the way across and go down onto the foundation, we should see this foundation should be concealed a bit more by liquid membrane, probably along here somewhere. But there's exposed wood, and it doesn't come all the way down. So we have a workmanship issue in this case, unlike the storefront example we looked at was a design issue. And in fact, a closer inspection here, even where the liquid membrane did come a little ways onto the foundation, there were still voids in that sealant that you can see. And so again, workmanship issue. They didn't get that bead in there, that bead of sealant in cleanly. And so these voids resulted in air leaks. So that kind of gives you, or shows you the other side of the spectrum, which is, yes, we can identify design issues during the construction phase testing, but we can also identify workmanship issues during the construction phase testing. And if the architect and I are working well together in design phase, most of what we find in construction phase should be workmanship issues, if we're going to find anything. It'd be a little depressing to find a lot of design phase issues, especially if we were involved in the design phase part of commissioning. And just lastly, I won't spend a lot of time on this, but this is just an interesting example. So this is a project where we were just a testing agent. We didn't have any involvement in commissioning. So we were just hired to come out and test and tell them what they've got, to put it, simply. Their air barrier for this product was also sort of their insulation. It was also their finish system. It was a product called insulated metal panels. I think, in fact, in the building science room 110 there, I think there may be some pieces of this on display if you get a chance to go in there and look. But there's the insulated metal panel system sort of is an all-in-one package for this building envelope. So it's supposed to be the air barrier, meaning wherever these panels join, at each of these horizontal joints, at each of these vertical joints, and at each of these intersections where four panels kind of come together in the corner, this is all supposed to be airtight, right? So just to show you the value of testing, you might look at that and think, looks good from here, looks airtight from here. But as soon as we took this tool out, this fog tool to test, all he is doing here is putting a little bit of fog. There's actually, you can't see it, but there's a hole right here in the panel that gave us an opportunity to put fog behind the panels. And so he did this, and just from putting a little fog right here, look at where it's coming out at each of these these four-way intersections of panels. It's just leaking, and it did that all the way up the wall. So it just kind of demonstrates the value of testing and how testing can help you identify issues that aren't being seen, that no one would pick up on otherwise, just by looking at it visually. So any questions at this point? I'm going to go into briefly the last phase here of sort of our involvement in commissioning, but I'll stop there for a sec. And this part will be quick. Good. Yeah, I mentioned this last phase, excuse me, post envelope or occupancy. So a lot of times, we'll do a few things here. There's this list of 4 items that you can look at. But we bring the most value really in final compliance testing. And I'd also argue this warranty review inspection. I won't get into that heavily, but I'll just mention a warranty review inspection is just to say, okay, the building has been lived in or it's been occupied for about a year now. How is it doing? Are there things that are falling apart sooner than they should be? Were last minute items missed by the builder? Was there a bead of, a finished bead of sealant somewhere, that didn't get put in, or things like that. It's just an inspection period before the installer warranty is up. Most contractors will warranty their work for about a year, meaning the workmanship for about a year. And beyond that, it's the cost of repairing anything falls on the owner. So we try to get in there and do a review inspection for the envelope close to the end of that warranty period, but with enough time for the owner to act on it while they still can without getting hit with a cost. So we do a sort of a post-occupancy inspection toward the end of a project, and that's really sort of our last bit of involvement in the project at all. And after that point, the building is fully in the hands of the owner, and we're moving on at that point. So I just want to mention that it is an important piece, but I'm not going to dwell on it here. I wanted to touch base on these final compliance tests. Most of our testing is happening right in the middle of construction, but I mentioned blower door testing, and you might recognize this building here. We actually did the commissioning for, I don't know what they're calling it now. They called it Pondside 4 when we were building it. I think it's a living learning center. Does that sound right? I'm not sure. But anyway, building on Keene State's campus that we commissioned and we did a blower door test for. It had a specific air tightness target. And I mentioned that fog testing during the construction phase to help facilitate the building reaching or meeting this air tightness goal that it has. So here we are post envelope. You can see the envelope in this photo. We're done. All of the brick is up, all of the air barriers covered. There's not really any fixing or getting to the air barrier at this point. We're really just here to verify that the air barrier is tight. And so, we do that through a blower door test. And so here's an example setup. You may have seen this before. Typically, this is where we go to 50 pascals of pressure. In fact, for this Pondside 4 or whatever it is called, this building was tall enough that we actually went to 75 pascals of pressure. And the reason we did that is when you get into tall buildings, of course, stack effect can be greater, right? So to overcome that stronger stack effect, we'll go to a higher pressure sometimes. Typically, it's 50 pascals. So really, it's just a test. After you configure the building to do the test, we get a number and see how the building stacks up. And ideally, if we had a good project team involvement through the construction process, this blower door test shouldn't be a big deal. It shouldn't be something to stress about, because if the team was on top of anything we were finding during construction, we should end up with a fairly tight envelope. And so this is really just to verify that and see where we came in. And I'll just mention, this blower door testing, it surprises a lot of people how big of a building you can test. And I'll give you an example. So this building here, top right, is probably somewhere on the order of 100,000 square feet or more. And to show you two extremes, this building had such an air tightness target to it that we actually depressurized the whole thing with just one fan. We got to our 50 pascals pressure with just one of these fans. And if anyone's ever done a blower door test, I don't know if anyone has that experience, but sometimes you can go into old residential homes, and if they're old enough and leaky enough, you may need, 2 or 3 of these fans to do one home that's maybe only a couple of thousand square feet. So the commissioning process can really help facilitate, like I said, can help facilitate a tight air barrier. And even buildings this large, you can, if it's done well and the builder is on board with the end goal, you can achieve some really great results. So this was a case where the builder was really sharp, really on top of all of the detailing when it related to the air barrier, and really took action on anything we found through that fog testing during the construction phase. And so the result was outstanding. On the flip side, here's a building that's tiny, right? It's probably, I don't remember, but I think it's somewhere on the order of about 1,000 to 1,200 square feet. And the total leakage on this building actually exceeded the leakage on this building, which is pretty remarkable when you think about it. A 1,200 square foot building versus a 100,000 plus square foot building. The leakage here, just in terms of raw cubic feet per minute of air at 50 pascals, was a higher number than the total of this building. And so the difference was we weren't involved in the design phase, for one, of the commissioning here. Nor were we involved in the construction phase. We were just asked to show up and test their building. And so without that commissioning process and anyone to help guide them during construction or during design, they struggled. These two buildings had the exact same air tightness target, and this one missed its mark by about 4 times. It was about 4 times higher than it should have been. And this one came in about 4 or 5 times below what it should have been. So it just goes to show, the bigger picture, which is commissioning is valuable. But if you don't have team buy-in to the process, our efforts can be meaningless. And so part of our role as a commissioning agent is not only to review documents, review design, test things, inspect things. It's also, you're trying to build a relationship, and you're trying to help get the team to understand why commissioning is important, why the envelope's important. Because a lot of builders still don't get that today. They don't, it's been John Smith, who's been building been building buildings the same way for 30 years and, is stubborn to change and, isn't used to all this stuff. And so it's part of helping educate and build an understanding of what we're doing to get to end results like we had for this building here. So, I mean, there's a lot more to all of it, of course, but in a nutshell, that's the commissioning process, and that's kind of a lot of what we do from day to day. One day we'll be in the office reviewing a set of drawings. The next we might be out on another project, testing details. And so what I do is a lot of office and a lot of field work. My role specifically is as a project manager. So I'm overseeing a lot of the commissioning efforts on you know, 15, 20, 25 projects at a time. So I end up being in the office a little bit more, but Quinn and Paul, who work just under me, they get a really healthy balance of uh, test experience and test work out in the field, and office experience writing reports and doing these design reviews, amongst, again, several other things that we do that I didn't even touch on today. But I guess I want to open it up to questions here. We've got a few minutes. Before I do that, I just want to mention, so part of this presentation, well, the point of this presentation really was to sort of open up this, open up your minds to the idea of envelope commissioning as a path, a career path potentially, or at least something to consider exploring. For me personally, I don't know about any of you, but when I went through the program at Keene State, I kind of got to my junior and senior year and thought, geez, I'm not so great at this design thing. I can't really draw too well. Feel like I should be able to. But then it kind of hit me. I took a lot more to the technical side of it, the scientific piece, and sort of the engineering sort of related aspects to it. And so it just so happened that my boss back in 2012 did a presentation similar to this then, and introduced me to this other thing that I knew nothing about. And so that's how I got involved in all of it. And I think it was the right path. I don't know that, for me personally anyway, pursuing my architectural license was the path I needed to head. So once I heard about this, it kind of became more clear. So that's the point of this, is to just show you this opportunity. And so we're hoping to offer an internship to to candidates this coming summer. And so if this is something that jives with you, reach out to me. My contact info is right there. If you want to, shoot me an email, feel free to write that down. I kind of glossed over BVH earlier, but BVH Integrated Services, I mentioned we're out of Connecticut. We're out of Massachusetts, but a lot of us are also working remotely as well. We're a first and foremost a construction engineering firm. So we have civil, structural, electrical, mechanical, and even audio-visual engineering design departments on board. But then we also have a commissioning and a building envelope commissioning department as well. So we're kind of a total package firm, other than providing big time architectural design services. But in terms of engineering services and commissioning services, we run the whole gamut. So before I keep rambling and run out of time here, are there any questions, things that weren't clear, anything like that?
I just wanted to ask real quickly, for the internship opportunity, where does that take place? Because I know you were saying there's a Connecticut office and a Massachusetts office, but I know you were saying that you guys were working remote too, so I was just wondering more about that.
Yep, so that's a good question. So I believe that is going to be pretty flexible. Just given COVID right now, most everyone's working remotely anyway. And as I mentioned earlier, the envelope department, our department's pretty small. There's 4 of us. It's myself, my boss, and then Quinn and Paul, who work just beneath me. So we're a small department. To give you some context, our department, I live, like I said, just outside of Keene in Chesterfield. My boss lives up in Fairleigh, Vermont, which is just north of Dartmouth College. Quinn lives even a little bit further north of him, the next town up, and then Paul lives down in Newton, Mass. So we're kind of already all spread out. So I don't quote me on this, but I don't think there's going to be, even if the office is open back up full time, I don't think there's going to be a requirement that you work at either of those offices. I will say, looking long term down the road, we hire an intern and we like them, and we want to look at the possibility of bringing them on full time as a full-time employee. Ideally, we'd be looking for someone positioned further south. That's just where we need more distribution. But for the purposes of the internship, I don't think it matters at this point.
Thank you.
Yep.
Okay, I have a question
Sure.
about these kind of jobs. So has the pandemic affected this in any way? Because now we are struggling in campus. Next fall, we will go back to teaching in person. And now they are struggling with the ventilation systems. We are lucky because a nice modern building, the TDS Center. We have a nice mechanical ventilation system. We have windows that open and close automatically. They have their sensors everywhere. But in other old buildings on campus, they are struggling with this. In Spain, the government has solved this, making the schools and universities open their windows anytime. I don't think it's a good solution here, especially in winter. But how do you think this issue can affect this commissioning? Because if we are looking for air tightness, and now we have to enhance the ventilation, how can this affect the job?
Yeah, that's a great question. And it might be one that well, I'll say it's one that we haven't had to explore yet because I don't think it's caught up to us. But I have heard our commissioning department, our general commissioning department, which handles mostly mechanical, electrical, and plumbing services, they are starting to run into this question. And so if I'm honest, I don't know what the solutions have been. I don't believe, and I certainly hope that, opening windows hasn't been, isn't the solution. But yeah, it's a great question. I honestly, I don't have a great answer for you yet, but certainly it's something we're going to have to think about down the road, because like you say, if suddenly mechanical systems are being altered in such a way to account for COVID, maybe there's an increase in ventilation requirements. In my mind, it may mean that, in order to offset increases in ventilation, for example, which is going to have a higher energy impact, it may mean that envelope commissioning or more, maybe in a broader sense, the envelope design is going to get that much more strict, much more stringent, in order to help keep energy use low, to help offset these increased ventilation requirements. I don't know. I think it all depends on ultimately where everything really lands, but I could certainly see it heading that direction, which would be good news for envelope commissioning, because if the need for tighter and tighter buildings or more and more efficient buildings increases, then certainly the need for our services will increase as well. And I think almost regardless of that, the trend so far, with codes getting more and more stringent anyway, the need for our services is has definitely been increasing over the years. And so, and I will say more specifically, as it relates to the pandemic and just the impact of what we're seeing for envelope commissioning, there was a period, obviously, when everything shut down, commissioning, our scope of work really died down for a while, and then it ramped up again. And then we had a lull in any new work coming in for several months. And I think we're now starting to come out of that. Restrictions are slowly starting to dwindle, and as we come into the summer months, builders builders and owners are really starting get anxious about building again. And so this past couple of weeks, we've seen a real uptick in the need for construction and the need for our services on board, on board with projects. So it's a good sign. Commissioning is where it's coming back online, so to speak. And the trick with it all is, of course, because of COVID and now because of the Suez Canal blockage and all of that, as most of us know, material costs are through the roof. And so what's happening as a result of these new projects coming online is building costs are now through the roof. So we're being pressured with providing quality services at a lower cost because owners just don't want to. They're trying to maintain their budget as best they can. They have to put it all in these higher material costs now, and so there's less room or there's less budget available to accommodate our services. So if we want to keep, that's the balancing act right now, is if we want to keep ourselves involved in projects and keep commissioning, keep introducing commissioning into projects, we have to work on striking that balance of proposing services that bring value but aren't inflating the cost of what we do. So that's the challenge we're really working with, today. Yeah.
Okay, thank you very much. I think it's been a great presentation. I hope the students have learned a lot about building science and building commissioning. And okay, thank you very much, Mike.
Great. Thanks, everyone. Appreciate your time.